The Sukhoi Su-57 has become one of the most debated fighter jets of the modern era. Designed as Russia's answer to fifth-generation air combat, it carries forward the legacy of the legendary flanker family while pushing into new technological territory. Yet, critics in the West often dismiss it as an imitation of American stealth fighters, questioning its true capabilities. This film explores the story behind the Su-57, its origins, innovations, and the controversies that surround it. The Su-57 is Russia's first fifth-generation fighter jet. It was created to compete with the American F-22 Raptor, which has been the standard for stealth fighters since 2005. The main difference is in the idea of stealth. The F-22 was built to be almost invisible to radar. The Su-57 reduces its radar signature but focuses more on speed, agility, and strong sensors to fight in difficult electronic conditions. This project has deep roots. In the 1990s, Russia tried to build a fifth-generation jet under the MFI program. The result was the MiG 1.44 prototype. But the project was cancelled after the collapse of the Soviet Union and lack of funding. The Su-57 became the continuation of those efforts. It uses lessons from past programs and adds new engines, avionics, and weapons. Its goal is to give Russia a modern fighter that can face NATO aircraft and operate in high-tech wars. Critics still argue whether it matches the F-22. But the Su-57 is a key part of Russia's Air Force and a symbol of its ability to develop advanced military technology. To understand how the Su-57 was born, we have to look at an earlier, experimental aircraft, the S-37 Berkut. Built by Sukhoi in the late 1990s, the Berkut was never meant for combat. It was a flying laboratory, created to test advanced aerodynamics, fly-by-wire controls, and the use of composite materials. Its forward-swept wing gave it extreme agility, and allowed engineers to study flight behavior at high angles of attack. The Berkut taught Russian designers how to build and control a highly unstable, maneuverable airframe. These lessons became critical when Russia decided to create a true fifth-generation fighter. In 2002, the Air Force launched the PAK FA program, the Future Frontline Aviation Complex, with the goal of producing a rival to the American F-22. Much of the technology proven on the S-37, from digital flight control systems to advanced composites, carried over into the design of the Sukhoi T-50 prototype, which first flew in 2010. This aircraft eventually became the Su-57. Seen this way, the Berkut was not a dead end, but the first real step toward the Su-57. It bridged the gap between Soviet-era experimental designs and Russia's modern stealth fighter, making it an essential chapter in the Su-57 story. The Su-57 stands out among fifth-generation fighters for its unique design philosophy. Unlike the American F-22 and F-35, which are built around maximum radar invisibility, the Su-57 aims for a balance between stealth, maneuverability, and performance. Its airframe is larger and shaped to keep aerodynamic efficiency high while still reducing radar reflections. One of the most noticeable features is its widely spaced engine nacelles. This gives the Su-57 a broad fuselage, which helps create more lift and allows space for large internal weapon bays. The engines are equipped with 3D thrust vectoring nozzles, which make the aircraft highly maneuverable, a traditional strength of Russian fighters. The tail design also shows Russia's focus on agility. The Su-57 uses all-moving, canted vertical stabilizers that also work as horizontal control surfaces, improving pitch control and helping reduce radar signature. Its blended wing body layout gives it strong lift at high angles of attack. letting it perform maneuvers that most other stealth fighters cannot safely execute. Many aviation experts note a visual similarity between the Su-57 and the American YF-23, the experimental fighter that competed against the F-22 in the early 1990s. The YF-23's long, blended fuselage, wide engine spacing, and canted tail surfaces are echoed in the Su-57's shape. While there is no direct link between the two projects, the resemblance shows that Russian designers were aiming for similar aerodynamic advantages, combining speed and low observability rather than sacrificing one for the other. Inside, the Su-57 carries an advanced sensor suite, including an AESA radar and side-looking radar arrays, giving it a wide detection range. Its large internal bays can carry long-range missiles, while its engines, once the second-stage power plants are fully ready, are expected to give a true supercruise capability. Taken together, these design choices show that the Su-57 is not just a copy of Western stealth jets. It reflects a different doctrine, a fighter that can stay hidden long enough to approach the enemy, then use superior maneuverability and diverse weapons to win the fight. One of the most debated aspects of the Su-57 is its stealth. Russian engineers never claimed the aircraft was as invisible as the American F-22 or F-35, but they designed it to be much harder to detect than older fighters. Western analysts, however, continue to question just how stealthy it really is. The Su-57's shape is partially optimized for radar evasion, with edge alignment, internal weapon bays, and canted stabilizers. But some features, such as its widely spaced engine nacelles and round nozzle design, are less effective at hiding from radar compared to the flat nozzles of the F-22. This has led critics to argue that the Su-57 sacrifices some stealth to keep maneuverability and performance high. Independent researchers have tried to measure its radar cross-section using computer modeling. One notable study by Aircraft 101 estimated that the Su-57's frontal radar cross-section is around 0.1 to 0.5 square meters, depending on configuration. This is much lower than a fourth-generation jet like the Su-27, but significantly higher than the F-35's estimated 0.0015 square meters. This means that while the Su-57 is harder to detect than most non-stealth fighters, it will likely be seen by modern radars at longer ranges than the F-35 or F-22. For Russian designers, this trade-off is acceptable. Their doctrine expects the Su-57 to operate with strong electronic warfare support, jamming enemy sensors and closing the distance where its superior agility and long-range missiles can be decisive. The debate over its stealth performance shows the core difference between Russian and American design philosophies. The United States built its fighters to avoid being seen at all costs. Russia built the Su-57 to be stealthy enough while still able to fight effectively once the enemy knows it is there. This makes the Su-57 a unique hybrid, not a pure stealth jet, but not a conventional fighter either. One way to reduce radar visibility is through radar absorbent materials, or RAM. These special coatings absorb radar waves instead of reflecting them, lowering the aircraft's radar signature. The Su-57 does use RAM across parts of its surface, including leading edges and engine inlets. Combined with its angular design and internal weapon bays, these materials play an important role in reducing detection range. But there are limits to how much RAM can help the Su-57. Unlike the F-35, which is built with a heavy reliance on advanced coatings and composite structures, the Su-57 uses RAM more selectively. This choice reduces cost and maintenance complexity, but it also means the aircraft cannot reach the extremely low radar cross-section levels of American stealth fighters. In addition, RAM coatings are fragile and degrade quickly under harsh field conditions, especially in Russia's varied climate. Applying them extensively would raise logistical challenges for long-term use. As a result, the Su-57 stealth is best described as partial. It is difficult to track compared to traditional fighters, but not as invisible as Western fifth-generation jets. This reflects Russia's design philosophy. Stealth is valuable, but it must be balanced with agility, durability, and easier maintenance. The Su-57 is therefore optimized to be stealthy enough to enter battle, but still robust enough to keep flying under real-world conditions. The Su-57's main limitation lies in its engines. Current power plants do not yet provide full thrust or supercruise, affecting performance and combat potential. Some focus on its open nozzles, but experts agree engines have a greater impact on stealth than nozzle shape. Heat and exhaust management determine how detectable the aircraft is. Future engine upgrades will define the Su-57's true capabilities, balancing maneuverability with partial stealth to meet Russia's air combat needs. The development of the Su-57 began before new engines were ready, which has caused significant delays in the program. Early production aircraft are equipped with AL-41F1 engines, similar to those used on the Su-35. While reliable, these engines are not optimized for full supercruise at maximum combat load. Earlier designs, like the AL-30, simply could not provide enough thrust for high-speed flight under heavy armament. As a result, the Su-57's performance is limited until its next-generation engines are fully operational, highlighting that power plants are the key factor in realizing the fighter's true capabilities. The AL-41F1 engines give the Su-57 exceptional maneuverability, thanks to their three-dimensional thrust vectoring. This allows the aircraft to perform tight turns and complex aerial maneuvers that most other fighters cannot match. Future engines, such as the AL-51, are expected to provide supercruise capability at speeds up to 1.5 Mach, significantly increasing the fighter's operational range and combat effectiveness. Alongside engine upgrades, designers plan to improve the airframe and materials to enhance stealth. These combined improvements aim to make the Su-57 not only highly agile but also harder to detect, securing its role in Russia's next-generation air combat strategy. The Su-57 is designed to operate alongside unmanned systems, such as the S-70 Okhotnik drone. These drones can support the fighter in both offensive and defensive operations, extending its reach and providing additional firepower without risking a pilot. To manage these missions, Russia is developing the Osnod Data Link System, which allows secure communication and coordination between the Su-57 and its drones in real time. The S-70 has already completed several test flights, demonstrating its ability to fly independently and integrate with manned aircraft. Although still in development, this combination of Su-57 and S-70 represents a glimpse into the future of Russian air combat, where manned and unmanned platforms operate as a single, coordinated force. The Su-57 program has faced significant financial and political challenges. The war in Ukraine and broader international tensions have raised questions about Russia's ability to fully fund the development of its fifth-generation fighter. Originally, Russia planned to build around 200 Su-57s, but these ambitions have been scaled back dramatically. India was an early partner in the program, joining Russia in 2007 to develop a fifth-generation fighter together. However, persistent delays and technical difficulties led India to withdraw from the project in 2018, leaving Russia to continue alone. As a result, the production plan was reduced to a single operational squadron of around 12 aircraft, far fewer than originally envisioned. These financial constraints and international complications highlight the challenges of maintaining a cutting-edge fighter program under pressure. Despite these setbacks, Russia continues to develop and upgrade the Su-57, focusing on improving engines, stealth, and combat systems to ensure it remains a capable platform in the modern battlefield. In 2017, Russia signed a contract for the delivery of 76 Su-57 aircraft. However, production has been slow, and as of now, only about 10 planes are operational. The delays reflect both technical challenges and the limited industrial capacity available to build such an advanced fighter. The Su-57 has already seen deployment in Syria and, more recently, in Ukraine. While Russian reports highlight its success in combat, analysts caution that some of these claims may be influenced by propaganda, and independent verification of its effectiveness remains limited. Despite these uncertainties, the delivery program continues. Each new aircraft provides valuable experience for pilots and engineers alike, helping to refine tactics, systems integration, and operational procedures. The Su-57 remains a symbol of Russia's ambitions in modern air combat, even as production and deployment face real-world constraints. The Su-57 is equipped with advanced electronics and weapons systems designed to give it an edge in modern air combat. At the heart of its sensor suite is the N036 Byelka radar, an AESA system featuring 5 separate antennas. This configuration provides wide coverage, enabling the aircraft to track multiple targets simultaneously in all directions, a capability critical for situational awareness in complex battle environments. Complementing the radar is the Infrared Search and Track System, or IRST. This system can detect heat signatures from enemy aircraft without emitting radar waves, allowing the Su-57 to locate targets stealthily and engage them before being detected. IRST is particularly valuable against low observable aircraft that are designed to evade radar. The Su-57's onboard computer integrates these sensors to create a comprehensive picture of the battlefield, similar in concept to the F-35's distributed aperture system. While the Russian system provides robust situational awareness, analysts note that it still lags behind the F-35 in data fusion, processing speed, and sensor integration. For weapons, the Su-57 carries a combination of internal and external payloads. Internal weapon bays help maintain low radar visibility while holding air-to-air and air-to-ground missiles, as well as precision-guided bombs. Combined with its advanced avionics and maneuverability, these systems allow the Su-57 to engage multiple targets effectively, from both long and short ranges. Together, the N036 radar, IRST system, and integrated computer give the Su-57 a modern electronic warfare and targeting suite. While not fully on par with Western fifth-generation fighters, it represents a significant advancement over previous Russian jets, ensuring the aircraft can perform both air superiority and multi-role missions in contemporary combat scenarios. The Su-57 has both strengths and weaknesses when compared to Western fighters. While it does not fully match the stealth and sensor integration of aircraft like the F-35, it surpasses many fourth and even some fifth-generation fighters in maneuverability, speed, and payload capacity. Its advanced engines, three-dimensional thrust vectoring, and agility give it a unique edge in close-range dogfights, where traditional Western designs rely more on stealth and beyond visual range combat. One notable limitation is the lack of a dedicated targeting pod for precision strikes. The F-35, for example, can use its internal targeting systems to accurately engage ground targets without exposing itself, giving it a significant advantage in strike missions. The Su-57, while capable of carrying precision weapons internally, depends more on pilot skill and supporting sensors for accurate targeting, which can limit its effectiveness in complex environments. In conclusion, the Su-57 represents Russia's most advanced fighter, combining lessons from decades of aerospace development with new technologies in stealth, avionics, and weaponry. Despite its limitations, it is a formidable platform that reflects a different design philosophy, prioritizing agility and versatility alongside partial stealth. As production and upgrades continue, the Su-57 will remain a key component of Russia's air combat strategy and a symbol of its continuing technological ambition. Friends, don't forget to subscribe and hit the like button. Your support allows us to continue creating videos and documentaries. Every subscription helps us produce better quality content for you.